So we've reached the final station of our cruise. We're about 2,000 miles from where we started off the coast of Chile, and we're sitting at the eastern edge of the South Pacific subtropical gyre. This is an enormous feature which stretches all the way across the South Pacific Ocean and is really the major feature that we've come here to study on this cruise. So when we started our cruise inshore, it was an upwelling system where nutrients which normally lie deep in the ocean were brought up to the surface and used there by the microbial communities. Out here, however, those nutrients stay deep in the water column, and that's where we find the microbial populations. And you can see that on this trace of chlorophyll here, where we have very low values in the surface of the ocean and very high values deep in the water column. But the chlorophyll maximum here, where we find the most chlorophyll, lies very, very deep, between 150 and 250 meters, and that's 3 to 5 times deeper than what we saw at the start of the cruise. It's not only deeper, but it's also much broader. So the entire chlorophyll feature here is about 100 meters across. And we've done some sampling of that today, and what we're beginning to see is that within that chlorophyll maximum, there are many different populations of microbes, and each of those populations is trying to optimize the amount of light that it gets as well as the amount of nutrients that it gets. So over the next few days, we'll continue to sample those to really understand what those different populations are and why they're located where they are. And what we'd like to do is compare the data that we're collecting here with another study site that we've been studying for the last 10 and 20 years off of Hawaii. It's called Station Aloha, and this is a place where we visit about once a month, and we have a lot of data on the chemistry and the microbiology of the area. And as we said at the start of the cruise, this region of the ocean is very understudied, and so there's a lot new out here, and we want to see how the microbial populations here compare to the ones we see off of Hawaii. How are they different? How are they the same? And if they're different, why are they different? So we think that by studying these two regions and comparing them, we can learn a lot more about the microbial ecology of oligotrophic gyres, which are really the major features in the oceans on the planet.
Just like all the other stations, Angel White from Oregon State University conducted a net tow to collect their microorganisms, but unlike the previous stations, nothing was found in the net.
These are some of the bluest waters on the planet, so we've seen a fundamental shift in the structure of the water column as well as the diversity and the nutrient cycling. And that's really, we knew what we were looking for, but now we've seen a shift from these large organisms to very small cells that are well adapted for making a living in a very low nutrient environment. So this blue water, the reason it's so blue is because there's very little phytoplankton there. They're not absorbing light, so we see this very rich, deep blue. I think one of the most important points about being here and studying this particular environment is these open ocean oligotrophic areas, these low nutrient gyres, these are representative of most of the global ocean, right? So if we really want to understand how the full ocean chemistry is evolving in response to changes in, atmospheric chemistry or physical forcing, studying these open blue waters are the key to unlocking that puzzle.